Hi, so we're back with the remaining lecture information on Unit 3, the atmosphere. So let's talk about why Earth's atmosphere is so unique. First of all, we have a lot of greenhouse gases, and that's a good thing because it keeps us warmer than we would be if we didn't have those gases. Without an atmosphere, our temperature would only be about 0 degrees Fahrenheit. Water, by the way, is one of the most important greenhouse gases. Water exists in all three phases, solid, liquid, gas. You can find it in each of those phases all over the planet. We have lots of patchy cloud fields. You notice when you look at these photographs of the Earth from space, there's always a large amount of white. Those are the clouds that are always in the atmosphere. That's drops of water. Air pressure, surface pressure, is a measurement of the weight of all of those air molecules above us. The more air molecules you add to a column, visualize a column going straight up above your head to the top of the atmosphere, there's pressure there. And we keep track of that air pressure. It's a pretty important weather indicator. If there's a lot of air in that column, you have a high pressure area. Take some of those air molecules away and it's a lower pressure area. Barometers are what we use to keep track of air pressure. Now, you'll notice that there's some numbers given here, but I would just say that when you listen to the weather report, many times you'll hear them talk about the barometric pressure is 29.9 and falling, or 30 and steady. The mercury measurement is the one that most the local weather stations use. Basically, this is about the average weight of the atmosphere, 29. It's about 15 pounds per square inch, but it causes the mercury in the column to be about 30 inches high. As the air pressure changes, this mercury rises and falls. And of course, in weather, and maybe you've noticed it, but you should listen for it if you haven't heard it, whenever the air pressure is falling, we're usually in for a change. We usually have some system coming in, clouds, maybe even rain. So it's a pretty important weather factor. Because of compression, the atmosphere is more dense near the surface, and then the density decreases as you go up in altitude. So let's talk about the vertical structure of the atmosphere. It's broken into 4 layers. The layers are defined by how the temperature changes within each layer. Let me show you a graph of that. Here, for example, if you just look at the graph, there are 4 distinct layers of the atmosphere. And this purple line on the graph shows you how the temperature, as you go to the left, the temperature is colder. As you go to the right, the temperature is warming up. So notice this zigzag pattern. So here we are down on the ground in the troposphere, the lower part of the atmosphere. The sun heats the ground in the morning, the ground radiates the heat up, and the air is actually heated from the ground up. Generally, as you go up in the troposphere, it gets cooler and cooler and cooler. This is where our weather occurs. This goes up to about 30,000 feet. Now, when you get to the next layer, the stratosphere, notice what happens with the purple line. Now, instead of the temperature getting colder as you go higher, it's actually getting warmer. This is because there's ozone in the stratosphere, and it heats up by the ultraviolet rays of the sun, and that causes an increased temperature with height. Notice at the boundaries between, see here the boundary between these 2 spheres, it's the tropopause. Here's the stratopause. These are little zones where the temperature stops changing and then it begins to go in the opposite direction. Here it was cooling, it stops cooling, and then it heats. It stops heating and then it cools, and so on. Third layer up is a mesosphere. It's about 50 kilometers and higher. There's very little ozone, so it's cool up here. And again, as you can see, the purple line is showing us that the temperature is decreasing with elevation. Oh, let me point out, do you see the meteor on this chart? Whenever meteoroid enters the atmosphere, it's dense enough in this zone that the meteor starts to burn up with from friction of hitting air molecules. So if you see a shooting star, know that you're looking at the mesosphere, because that's where they actually become visible. And then the top layer of the atmosphere is called the thermosphere. The air molecules are very far apart, but each air molecule is very hot. That's because there's so much energy coming from the sun. Nuclear particles, X-rays, gamma rays, and all of that heats up those air molecules. They're moving very fast. And then you also might notice the colored lights here. If you've ever been close to Canada in the summertime, maybe you've seen the northern lights, the aurora. That's the interaction of charged particles from the sun that interact with our magnetic field. Now let's just say that it's pretty important that we have these layers of the atmosphere. They are blocking ultraviolet light that would damage our human cells and other life on Earth. And they shield us from a lot of dangerous energy. So it's a good thing that we have them. Other planets, they talk about having a colony on Mars, but Mars has really a very, very thin atmosphere, like 1/100th as thick as ours. And we would definitely need some kind of shielding to live there, because the radiation would be hard on us over time. Okay, well, get on to the lessons, and each lesson will have links to the text, so you'll read more about all of this information. Thanks.